Bismillahirrahmanirrahim. Welcome back to Chemistry IGCSE lesson series. Today we will continue our fourth lecture with on unit number 1, particle and purification, with this chemistry course book Essential Chemistry for Cambridge IGCSE second edition. In last three lectures from unit number 1, we covered chapter 1.1, 1.2, 1.3. In today's lecture, we will talking about chapter number 1.4, that is diffusion. As in last chapter 1.3, we studied that Brownian motion and diffusion both provide evidence for the kinetic particle theory. So quickly recall our previous lessons. So first, Brownian motion. Brownian motion is the random irregular motion of tiny particles suspended in a fluid resulting from their collision. These small particles exhibit faster movements, lighter particles obtain greater speed from collision. The lower the viscosity of the fluid, the faster the Brownian motion. Diffusion, the random movement of different particles, so they get mixed up, is called the diffusion. And simple diffusion is when ions or molecules diffuse down the concentration gradient, that means from an area of higher concentration to an area of the lower concentration. Now we will give some detail of diffusion with different states of matter. So first we will see diffusion in gases. Diffusions occur in gases because the molecules in gases are constantly moving, colliding with each other, and changing the direction. This results in the gaseous spread. So we can understand it by taking a glass jar which is filled with the colorless oxygen gas, another jar which is filled with the bromine gas, bromine vapors, or these are the brown color. Okay, then if we put the jar of colorless oxygen above a jar of brown bromine vapors and remove the cover, then the molecules of the bromine vapor and oxygen gradually mix. After some time, both containers have a uniform color, just like here. Okay, so why here one question arises, that why it takes time to mix together? It is the reason because the oxygen and the bromine molecules are colliding with themselves, and not only colliding with themselves but also colliding with each other. What is the meaning for this one? That bromine molecule collide with bromine molecule, oxygen molecule collide with oxygen molecule, and the bromine molecule collide with oxygen molecule, and vice versa. Okay. Now we will see that the rate at which different gases diffuses. Actually, it depends on their relative molecular mass. At the same temperature, molecules that have a lower mass move faster than those with a higher mass. With the same amount of energy, lighter particles diffuse faster than the heavier particle. For comparing the speed of diffusion, we can do one experiment here. First of all, we take a neat and completely dry glass tube, okay, and then clamp in a horizontal position like in this way. Take cotton wool soaked in a concentrated hydrochloric acid. This concentrated hydrochloric acid, what it will do? It will give off fumes of colorless hydrogen chloride. So push the soaked cotton wool into right end of the glass tube here. Then take another cotton wool and soak in ammonia. And this concentrated ammonia solution gives off colorless ammonia gas. So push this soaked cotton wool end into left end of the glass tube. Now putting bungs or the stopper into the end of the glass tube. Why we put this one? Because to reduce the quantity of the gas to escape and produce the smell. Now watch the tube. These gases diffuse along the tube. After a few minutes, a white ring, just like here, is seen nearer one end of the tube. What is this meaning? It means that the molecule of ammonia and hydrogen chloride have diffused. When the molecule of ammonia and hydrogen chloride collide with each other, they react and form a white solid that is called the ammonium chloride. So we observe a ring here near to the hydrogen chloride end of the tube. This shows that hydrogen chloride is heavier molecule and than the ammonia. So ammonia move faster than those of the hydrogen chloride. Is it clear? Okay. This was the diffusion in gaseous state. Now we will see diffusion in liquid and also in the solution. Diffusion can also happen in liquid. This is because the particle in liquid can move around each other, which means that eventually they are evenly mixed. For example, if we put a drop of ink into some water and leave it, the color of the ink will spread throughout the water. Okay, then same thing, diffusion in solution is also important. When solid dissolve in liquid like sugar or the salt, these particles dissolve in water and finally their molecules are spread throughout the water. Okay, you see the when perfumes are let loose in a room, their particle mix with the particle of the air. Finally, spread through the whole room from an area of high concentration to an area of lower concentration. The rate of diffusion is slower in liquid than in gases because there are weak attractive forces present in liquid. So particles in a liquid move less rapidly than the particles in a gas. Now we will see diffusion in gases. Diffusion in solid. Diffusion in solid is rare but happen. It occurs in solid and it is extremely slow at room temperature. Like atoms of gold and lead will diffuse into each other if the surface of the two metals are in a close contact. If, if left for years in close contact, the lead and gold appear to be completely stuck together. Some of the carbon atom in the iron alloy can diffuse into another metal when the two metals are placed in contact. And an important application of diffusion in solid involves adding doping metals atoms to a silicon microchips. These are the key points that diffusion is the random movement of particles. This random movement leads to mixing up of the particle of different gases. Diffusion in two miscible liquid is slower than diffusion in gases. The rate of diffusion depends on the relative molecular mass, and the last point, substance with a higher relative molecular mass diffuse more slowly than those with a lower relative molecular. And in the last slide, these are the summary question. Now, I hope that after explaining in detail the diffusion, now you can solve these questions easily. Okay, finish.